looking at what a lot of you guys did. Like a lot of us had the right idea or the right start, but maybe some of our follow through wasn't great or whatever. So let's take a look at that. So we'll just start with number 1. Is that okay with you guys? Yeah. So I know right away by looking at these pieces that if I'm looking at my graph, I'm bounded above the x-axis from the y is greater than or equal to 0. I'm bounded to the right of the y-axis from the x is greater than or equal to 0. And I'm bounded between 0 and 8 then for the x is less than or equal to 8. So I'm working in this well somewhere. Whatever my solution set is, it's going to be inside of this little well. Is everybody okay with that? Yes. Of course. Okay. So now let's look at these two. So if I rearrange this one, I have negative 2y less than or equal to negative x plus 7. When I divide by negative 2, I have that, right? So to graph this, I'm just going to use 2 points. I'm going to use the x values of 0 and 8. Why 0 and 8? Because the only part of the line I care about is between 0 and 8, right? Does it really matter which ones I pick? No, not really, but that's what I'm going to do. So for 0, I get negative 3.5, and for 8, I get 0.5. So there's my line. Everybody's okay with that? Mia? Oh. Yeah. Yeah, definitely would be. You know, like every once in a while we make mistakes, right? It's the first I've actually had to do anything in any of my classes here. Everybody else has been working on reviews. So right now, this is the part, but I'm above this, right? So the only part that I've eliminated from that well is like this little bitty tiny corner here. That my solution can't be in that little itty bitty corner. But everything else is still fair game. Everybody's okay there. Okay. So now we'll rearrange the other one. So I'll add the x over and then divide by 2. And once again, I'll pick some x's. I'll pick my x to be 0 and 8. I don't know why my OneNote's been doing this all day. It's having a seizure. So I have 0 and 1.5, and then 8 and 5.5 is that piece. So the part that I care about then is this part right here. Is everybody okay with that? That's my convex hull. Joe?
So do the lines need to be in those spots?
Do the lines need to be in those spots?
Like just like one trigger.
Sure.
Like, I think this line's up somewhere,
Probably.
but this one I don't really know what happened. Like, is this,
It just has the wrong slope.
so this, would this like convex will not be right?
I mean, almost correct, because it should be going like this.
Oh, okay, so that's it. Okay.
And that's probably the only issue. Is that okay?
Yeah.
All right. So, our solution then, our solution set is going to come from one of these vertices for our convex hull. So where are the vertices on this convex hull at? There's one here, there's one here, there's one here, there's one here, and there's one there. Everybody's okay with that? Those 5 places are my corners. And I don't think I need to solve a system to get any one of these corners, right? Because the 2 lines that we have that are non-vertical or horizontal don't actually intersect, right? Which is nice. That makes life pretty easy to just read the points from our graph. So let's see. A is 0, 0. B is 0 and 1.5. C is 8 and 5.5. D is, what was that? Right here. It's 8 and 0.5. E is the only one we have left to actually find a little bit, right? Because everything else was a point we plotted or an obvious intersection. Everybody agree with that? So far, so good? How are we going to find that point E? Well, I'm just going to take the equation. Y equals 1/2 x minus 7 over 2. That's the line that E is on. And what is the y coordinate that point E has to have? Well, if it's on the x-axis, it has to have the y coordinate 0, right? So if I solve for x, I get x is equal to 3. I hand waved the solving there, but I trust that you guys can solve an equation that looks like that for x, right? That should be pretty easy. Okay, so these are my yes. Well, oh, sorry, it should be 7. Thank you. Well, 7 times 1/2 is 3.5, and then minus 3.5 gives us 0. Right? So yeah, it's not 3, absolutely. But it should be 7. Thank you. Appreciate that. Okay. So one of these 5 is, or more, could be, we could have a tie for first place, would be our solution, right? How do we check to find out which one or ones of these we want to use? Yeah, we just plug them into the maximum, or the cost function there is what we call that. So for A, the cost is 0. Maybe we should write out the word cost. We already used C. For B, the cost is 3. For C, the cost is 24 plus 11, so 35. For D, the cost is 24 plus 1, so 25. And for E, the cost is 21 plus 0, just 21. So that's our winner. So the answer is x equals 8 and y equals 5.5. Joe. Sure. I was just going to go ahead and do 2, since it seemed like that gave everybody a lot of issues. I was just going to kind of keep going. Is that okay? Okay. Yeah. The picture was maybe difficult to come up with. Are we good with this? Can I move forward? And hopefully, that one I felt like should have been realistic, that most of us could have gotten that or gotten pretty close to it, particularly since there wasn't a lot of solving a system and actually relatively to do. Two's a bit bigger pain in the butt, though, right? Look at all these lines. Yuckarowskis. All right. So we'll do like plot one of them manually, but then I'm going to use the computer to start generating the rest of this because yuck. All right. So just taking the first one, we'll add the 5x over and then divide by 7. And then we'll just pick some values for x. So 0 seems like a good one because I'll get a whole number result there. And then if it's me, I'm picking 7 for my next x. Why would I pick 7 for the next x? Because 7 times 5/7 doesn't give me a fraction anymore. That'll make it a lot easier to plot. And now I'm on my way, right? But I promised we weren't going to actually do this manually because, well, it's not a lot of fun. Oops. Use my friend here, Graphmatica. To do this. So negative 5x plus 7y. And I'm going to do these as equations because if I do them as inequalities, it's going to do all the shading and then it's going to get too messy to really handle. I'll kind of deal with the shading in our head at the end. I think it will probably be the easiest way to do this. If I put in all the shading now, it's going to get rather overwhelming. But so far, we're talking about below each of these two lines, right? So we're looking at this region right in here so far. Everybody agree? Okay. So then we have negative x plus y equals 3. So now we've shaved a little bit off here, right? So now we're talking about just this region. We've cut off this little tiny triangle up here. Okay, 51x plus y equals 39. And we are less than that. So now we're down in this spot down in here. So this yellow line becomes irrelevant, right? Okay, then negative 3x plus 5y equals negative 29. And we're above this spot, so now we're in this region here. Everybody okay with that? Okay. And we have x minus 2y equals 5. And we're below that one, so now we're down in this region down here. And then our last one is 6x plus y equals 3. And that one doesn't do anything, right? Notice if we're supposed to be, oh, it's bigger than that. So it doesn't really do anything, right? It's just gonna, oh, wait a minute. Oh, what does that do? Anybody? Yeah. Yeah, it did. I think that was my mistake, and I think that was supposed to be going the other direction there, that inequality, but that is what happened there. So let's fiddle with our grid range here a little bit and get a little bit better of a picture, and we'll kind of sum this up. Do this. Above this one. Okay, so until we put that last line in, our solution set would have been that piece right there. Right? Is everybody okay with that reasoning? Unfortunately, when we shaded that other line, it was a greater than, so it's talking about this part of it, and there is no overlap anymore. I think that was a mistake on my part, that probably should have been a less than. So let's pretend it was, so that we can actually do this for realsies. Okay? So if I look at that, I see 1, 2, 3, 4 possible solutions, 4 vertices. Everybody okay there? Now I'm going to find the solution, or I'm going to find the points of those intersections. Should have been labeling these points or these lines as they came in as like L1, L2, L3, so I could remember which one is which, huh? That would have been a good idea. Let me go back to the graph because I can do that from here. But I want to be able to look at that. Okay. So I'm going to just call these A, B, C, D, E, F, all the way down to G. And I'm just going to label these here on the graph. So that one is A. This one down here is B. Sorry guys, that wasn't A. Oh, I'm sorry. Yes, this is A. That one is A. That's B. Okay. This one is C. This one is D. This one is E. This guy is F. Oops. This one is G, excuse me. And B is somewhere off the screen. Okay. Sorry that we didn't do that as we were going. That would have made life a lot easier. Okay. So, if I look, this point here is the intersection between E and C, right? So that's the first step in a song. So, E and C. C is here. And E is here, right? That's what we said. Okay. So to solve that system, let's do it by elimination. I'll do -3 times C plus E. So that's going to give me 3x minus 3y equals -9. And then E didn't change. So y is equal to -19. And when I plug that back in, that was -22, -19. What is this? OneNote, you're just clearly having some issues today. Is this frustrating for you guys? It's frustrating for me. Try this. We're just going to try shut down OneNote if that clears these lagging issues up. And if they don't, maybe we'll just have to restart the computer and come back to this. But at this point, hopefully you guys are getting the picture, right? It's just going to be kind of a... But we've done the hard part at this point now, where we got to do is solve a couple of systems and then plug those answers back in to see what worked or what didn't. This problem is far too involved. Question. I think that 1 would be a reasonable thing to ask you to do on the test. Or even a situation where, like, probably in terms of a test, even in the interest of time, I would probably give you the thing already done. Like, give you the picture already constructed so you don't have to waste your time doing that. Oh my God. I don't think it was just OneNote. I think it's my whole computer that's being a problem. Oh my goodness. All right. We're just hard restarting this computer. So Janet, sorry for those of you watching at home. I'll be back in just a minute.